Telecompany Douglas Production and Svetlana Productions movie explanation of one half wave. Sponsor of program Svetlana Konzen, Director of stage Svetlana Konzen and actor Douglas Konzen. Sponsor of program Douglas Konzen. Enjoy the video.
Alrighty then, so I'm starting where I left off last time. I'm filling up this capacitor, DC capacitor from a full wave bridge. So I'm rectifying the AC coming out of this secondary coil here, the output coil. And I'm monitoring the AC volts across the cap bank here. It's 163 microfarads. So that's going to be on this meter AC volts, caps AC. The DC in this cap is going to be here. And what I'm going to be doing is I'm going to have two inverters. I'm not going to do this today, but this, I call it the reel. This is the inverter that's supplying power. And to the primary over here. Well, this is going to be a dummy inverter, and I'm going to be running a 40-watt light with this inverter. So the idea is this will be, when it's in looped condition, this should be about the same resistance somewhat, but it'll, instead of just plugging it, the DC I make from the cap into here, I'm going to have a load on it too. So this is kind of a dummy load, and then I can tune the caps and everything to what it needs to have to plug into the inverter when I loop it. So I have kind of a second inverter so I can tune the caps in the mimicking the looped condition. If any of you got that. So here's the AC lines. There's a blue and a yellow, and they go to the full wave bridge rectifier. And then the DC out of the full wave bridge goes to the cap. And here's where I'm monitoring the voltage. Last test I had the meter in AC volts, and I got like 64 volts. But now I'm making sure I have it in DC volts here. So I think it's going to be about 36, 38 volts. That's what it's going to say, because I ran it just a little while ago. And I have the very thick wines in the secondary, and I took out a lot of wines, and in the previous video I showed 15.8 volts AC coming out. And I thought that would be about right. So this is going to be the volts, and I think it's going to be about 18 volts. Okay, I have a bunch of circuits I wrote out. Explain things better. Let's run this right now, and we'll see what we get. Hold on one sec. Okay, so without the center shorted, you're going to have a flow when you, and this is actually inducing over here, sorry, but it's kind of the same thing. So let's say it's north and south, so it's going to go around like this, a magnetic flow. But the it's just going to keep to a loop here, and it's going to keep to a loop here, like that. But when you, and remember this is just a half sine wave in AC, but look, when you short out this center phase, it creates kind of a null, neutralizes polarity. Shorted B phase neutralizes polarity. And now if it's north, if the direction of current flows like this and this, so let's just say like this, the back EMF opposes it, so it shoots this way, okay? But guess what? This is neutralized here, so it'll go all the way over. And if this is north, the back EMF will be south. And it's going to go all the way here. Magnetic attraction is just going to go, back EMF is going to go, oh, I like this. So this would be called a shunt bar. And so the back EMF goes all the way here, and it runs through here, and they call this a reverse induction generator. So the back EMF flowing through here creates power. It's like running a magnetic ball through a coil, except it's traveling through the core. Now you've created power here. So actually there'll be a secondary back EMF produced, which will shoot over this way and do the same as up here and come back in here. So the back EMF actually completes a whole loop, and when it enters the back into the primary from the butt end of it, it's reinforcing power, making more power, plus it's displacing the power input, so it draws a lot less power because it's getting this back EMF assist going on. So, and when you get rid of back EMF, now you don't have these restrictions and blockage and heat and vibrations you get when something's in ferroresonance, because the back EMF has been taken care of. Just checking to see what's happening. So I've been running this all this time. Still have 19 volts in here. 19 volts in the cap bank too. Interesting. So, just dropped again. Okay, so one more time. The purpose of this light bulb across the capacitor bank is not the power output. It's kind of a ferroresonant reactor thing. Very simple. You put paralleled light, incandescent light across a big cap bank, and it just like bang, 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 and the core goes crazy. Let's see. Now this is a little more advanced. So what I'm doing is, oh, you know what? So what you do is you have a full wave bridge rectifier rectifying the AC from the cap bank into DC, and you fill up the DC cap, okay? But what you do is that you only have it activated, actually doing here, see this? I touch this, now the voltage in the DC cap is up to 37. And notice it doesn't really affect the output. It just goes down or up just like 0.1 volt on the 163 microfarad cap bank. So what you do, notice I say here, if any of you worked with a rotoverter and you have transformers hanging off the run cap phase, you know exactly what this is about. It's not going to work. It's not even going to run if you have the full wave bridge connected. So you bypass it. So you put a switch across the AC, you close the switch, and that'll bypass the full wave bridge rectifier. Short it out. Basically the AC side, full wave bridge rectifier right here. So what you would do is you'd start up the whole thing, fill up the AC caps, get the core and ferro resonance with the light and the capacitors, and then open the switch. You close it to start and you open it to run the load. And that will be the DC cap, which is going to be connected into an inverter as the load. See that? So here it is. Full wave bridge. I ran out of room up here, but basically to the cap positive, to the load positive, negative to the cap negative, to the negative on the load. The load will be an inverter or a battery to charge, just straight battery to charge. So it's kind of interesting how you close the switch and it bypasses the full wave bridge filling the DC cap. You open it, and now you hit the load with power from the DC cap. You fill up the DC cap when you open. I said run load here. Okay. Okay, I'm just about done with this, so hold your horses. Okay, this is during 1/2 wave. I already explained what 1/2 wave is. Now, here's the primary, 120 volts in. You have the secondary center shorted, center phase shorted out. So you create a crossed out, it's null, you could call it. That allows the back EMF, which would be south, if this is north, the south to shoot right across and be magnetically attracted to the north of this core leg. Have that backwards. This is the primary over here. The north back EMF opposes the current flow. The current flows this way. Back EMF is south because this is north. So it's south. It goes over here. It wants to go into this coil, and it does. When it does go through this coil, it induces power from the back EMF. They call it a reverse induction generator. Now, the back EMF down here would now, it's normally a south, because this is north and south. As the back EMF flows through and makes power in this coil, the secondary, here's the primary, this is the secondary, it's going to be south down here. The back EMF is not going to change the polarity of the coil. And the back EMF is not going to flip its polarity, but what's going to happen is it's going to create power in here, and it's going to be north-south again. And guess what? The opposing polarity of south is north. So this is, I call this the secondary back EMF. This is the primary back EMF flow. It creates another power, coil of power here. It'll be south on the bottom. And now you have another back EMF flow going opposed to the current direction. That makes sense. It's just created power here. So this is north, and it zooms across and is magnetically attracted to the south over here. So you have this primary back EMF comes in here, secondary back EMF comes in here. Okay. Okay, that's over with. So this is what I'm doing now. Here's the switch. My switch right now is I touch this. Okay, watch. Here's the DC cap. I just filled it up by touching blue to blue here. So that would be the switch right here. And it's looking pretty good, I think. I'm going to have to do something to, I could put a really big cap here maybe, so it doesn't fill so high, but the easiest way is to put a DC to DC buck converter. I have one here somewhere. It's downstairs in the garage somewhere. I'd have to really look for it. I ordered 3 12 amp ones. Heliarc Flint gave me a link to some super efficient ones. And maybe I'll get one of those too. So there we go. I'm trying to think of something else. So probably next video I'll have this dummy inverter hooked up, and I'll be shoving this into the dummy inverter and then tuning the caps. I might just be able to get this voltage down by adding or subtracting cap values on the AC cap bank. Okay, I think that's about it. Pretty exciting, 20 minutes, sorry. Okay, thanks for watching.